Hi everyone, welcome back to my channel. If you haven't subscribed to my channel, you kindly subscribe to the channel. There's a lot of stuff that I'll be working on. So yeah, kindly subscribe to the channel. Let's build a community together. I have a lot of videos here that comes with a bunch of knowledges that you will learn. So kindly subscribe to the channel and let's grow the channel together. Um, Without further ado, let's look at what we'll be working on today. So basically today we are going to work on AWS Three Tier Architecture. In my previous video, I created a video on how to set up AWS Two Tier Architecture. This time around, we are going to discuss the Three Tier Architecture by adding the database layer to our app tier, and then the web tier. So basically, we are going to be doing this in the North Virginia region. So we are going to have two public subnets for private subnet, a load balancer, and NAT gateway that allows the web tier to communicate the private subnet or applications in the private subnet to communicate with the web or the front end layer of your application. And also, we are going to have an auto scaling group as well as security, how to create security groups. So let's jump right into the tutorials for today. So I've already signed in into my AWS account. As you can see, I already have a VPC that I've created. So we are going to use this VPC to design our three-tier architecture. Okay. So first of all, what happens behind the scenes when, let's say, you are shopping for an item on your favorite e-commerce website. Now what I'm going to do here is that I'm going to demonstrate how companies ensure their website is always operational by explaining how a three-tier architecture works. So basically, a three-tier architecture is a commonly used software application architecture divided into three distinct tiers. So we have the logical and then physical. So I mentioned the web tier, which is more like the presentation layer or the front end layer of your application. So the web tier sits at the top of the application. This is because a user interacts with the application. It is responsible for collecting information from the user and displaying the content in a graphical user interface, desktop application, or a website in your web browser. For example, a web page written in HTML, CSS, and JavaScript will run at the web tier. The web tier communicates with the application and the database layer. Now the application tier, aka the logic tier, is where the data processing occurs. Think of it as a bridge between the web tier and then the database tier. The application tier is typically developed with various programming languages like Python, Perl, PHP, and Java. And finally, the database tier. The database tier is where all the information processed by the application tier is stored and managed. Some common database programs are MySQL, Oracle, and MongoDB. Alright, so let's look at some of the benefits of a three-tier architecture. So one, improved scalability. So sudden spikes in traffic are easily handled in an automated fashion with EC2 instances running in an auto scaling group. So as you can see in the design, we have an auto scaling group here. All right, and the second benefit is improved reliability. So deploying servers in two different availability zones ensure that the application will continue to run if one zone goes down due to unforeseen circumstances such as natural disaster or power outages. Yeah. And then the third one, we have increased security. By using security groups, we can effectively filter traffic from the web tier to the database tier, preventing malicious exploits. So as you can see, we have our security group on both the public subnet and then the private subnet of the app tier. Okay. All right. So let's take a scenario like this. So relatively a small e-commerce company wants to take advantage of the cloud's scalability, reliability, and improve security by deploying its website on AWS using a three-tier architecture. The web tier will collect data from users and deploy content and display content. So the application will process all incoming data such as items purchased, payment information, and shipping options. Now, the database tier will store all the data such as transaction data, customer information, and product information. All right. So in an instance like this, what would be the solution? So the solution is the web tier will include the EC2 instance running in an auto scaling group to handle increased traffic during peak sales seasons. These instances will be placed in two public subnets in two different availability zones, allowing public access to our servers. Now, the application servers will run on EC2 instance, running into an auto scaling group in two private subnets in two different availability zones to protect the application tier from being accessed directly from the internet. So basically, we only allow inbound traffic from a web server security group. And then finally, the database tier will utilize a free tier MySQL RDS database that can easily scale the platform to grow. So the database instance will be placed in one private subnet, even though we will create two different subnets. Only incoming traffic will be allowed via the application server security. So by utilizing three-tier architecture, the e-commerce company can benefit from reduced overhead, less manual intervention, increased reliability, scalability, and improved security. All right. So what are the prerequisites for this tutorials? One, you need an AWS account and also AWS CLI access. All right. So like I said earlier on, you need to have a VPC that is already created. And as you can see here, I have my VPC that is already created. All right. So what we are going to do is to yes, for the sake of these tutorials, I'm going to create another VPC in the North Virginia region. Yes, in the North Virginia region, so that we can all see and learn. Yes. So all right, so let's click on create a VPC. We are going to choose VPC only because I want us to follow and understand what we are doing. I can go with VPC and more, and this AWS will automatically spin up the VPC infrastructure for me. But if you are not yet an expert, I suggest that you go through these options. Once you are doing it, you understand IP configurations and security groups and other stuff. This gives you a much better understanding to how the AWS networking architecture operates. All right. So what we are going to do is, let me give this a name as three-tier demo. All right. So we are going to give it a CIDR range of 10.10 10.10.0.0/16. So this will basically give us 65,536 IP addresses. All right. So the next thing that we'll do is to I think we'll go ahead and then create the VPC. Okay. So now that our VPC is created, the next thing we need to do is to set up a subnet for our VPC. So remember when we created a VPC, we had 65,536 IP addresses. Now this IP address will be shared among the subnets. Yes. All right. So let's create our subnets. We click on the create subnet, select the VPC, which is our 3-tier VPC. The next thing is to give our subnet a name, so we can say 3-tier dash public subnet or pub subnet 1. And then availability zone, it will be in the A availability zone. So the CIDR for the VPC is already selected. We'll give our CIDR, our subnet, our public subnet, a CIDR block of 10.10.1.0/24. Yes, and which will have 256 IP addresses for this particular. So we'll go ahead and click on another create subnet. So that will be our public subnet 2. So this will be 3-tier pub subnet 2. Availability zone will be in the availability zone B, and then we give it a CIDR range of 10.10.2.0/24. Yes, and then we'll add the 4 public private subnet. So this, the third subnet, will be our private subnet. So 3-tier dash private subnets 1, and that will give us that will be in the USS 1A, and then a CIDR block of 10.10.3.0/24, and then we'll add the 4th private subnet, so 3-tier dash private subnets 4. So we have our okay, so this will be our private subnet 2. So availability zone, it will be in B, and then we'll give it a CIDR of 10.10. This one is so 4.0/24. Okay, so we are going to have 6 subnets. So this is private subnet 2. So let's create a private subnet 3. So 3-tier private subnet 3, and this will give us, this will be launched in, so this one is in B, this one will be in A. We'll give it a CIDR of 10.10 dot. So this one is 4. So this one will be. So we are creating our for our last private subnet, which is the set private subnet. So 3-tier private subnet, 6 private subnets. So this one is 3, so this will be 4. Okay. And then, so as you can see, the VPC CIDR is already selected. Let's give it a CIDR of 10.10. This one will be 6. Yes. So 6.0/24. Okay. So now we have our 6 subnets created. We are going to click on create subnets. And this is going to create all our subnets that we created. So we have 2 public subnets and then 4 private subnets. So as you can see, our subnet has been created successfully. Now the next thing is to set up our. So we are going to configure our subnets to ensure that our EC2 instance can be publicly accessed from the internet. We need to configure our 2 public subnets so that IPv4 addresses can be automatically assigned. We will configure each one separately by following just follow the steps below. Just follow the steps below to create the. So just follow the steps below to create. Just follow the steps to create them, to ensure that, to edit our subnet, to ensure that the public subnet or the applications that will be deployed in the public subnet have IPv4 addresses assigned to them. So what we are going to do is to we'll select the first public subnet, which is this one, and then go to actions and then edit subnet. So here, this is what we do, and check this: enable auto assign public IPv4 address. Now the aim here is to ensure that the EC2 instances can be publicly accessed from the internet. Okay. And then once that is done, we click on save. And then we'll repeat this also for our public subnet 2, which is this one. So go to actions, click on edit subnet settings, and then check this to assign the public IP address. Click on save. Okay, and that is it. Now the next thing is to create an internet gateway. So we need to create an internet gateway and then attach it to our VPC. So let's create an internet gateway. Give it a name: 3-tier dash internet gateway IG. Okay, and then click on create internet. So now that our internet gateway is created, we need to attach it to our VPC. So we click on actions and then select attach to VPC. Select the VPC directory, which is 3-tier demo, and then click on attach. So now our internet gateway, so this basically to allow traffic from the internet into our VPC and resources that needs to be accessed publicly. Alright, so now that our internet gateway has been attached to the VPC, The next thing we'll do is to create a NAT gateway. Remember, the private subnets, that resources that will be deployed in the private subnet do not have internet access. So the only way they can communicate with the public subnet is to ensure that there is a NAT gateway. So we'll create a NAT gateway. So click on create a NAT gateway. Now let's give the NAT gateway a name as 3-tier dash NAT gateway, and then select the subnet. So which subnet? Remember, when you look at the application, we are deploying the NAT gateway in the public subnet. So both public subnets. So public subnet 1 and public subnet 2. So basically we'll select the first public subnet, which has to do with public subnet 1, and then click on public, and then we need to check we need to allocate an elastic IP address. So click on here, and then so as you can see, that has been done. The next thing is to select create NAT gateway. Okay. We'll create another one too for the public subnet 2. So 3-tier dash NAT gateway. So we can set it as 2, and then select the subnet. Remember, this will be in the, when you look at the diagram, this should be in the public subnet 2. So let's select our subnet, and that will be public subnet 2. Let's see what we have. So this public subnet 2, we select the public subnet 2, also public, and then allocate an elastic IP, which is done, and then we click on create NAT gateway. So now that our NAT gateway is created, we need to edit our route configuration. So whenever we created our custom VPC, a main route table is created by default. The main route table is also associated with all of our subnets. So this means that the subnet having been explicitly associated. So they haven't been associated with the route table. We can see evidence of this under the resource map. So let's go to the route tables, and then now let's go to the VPC. So let's select the VPC. Now let's go to the resource map. So this is the resource map. As you can see, yeah. So this is the resource map and all the subnet that we created, and this is a route table that has been created. So you see route network traffic to resources. So this is the route table that has been created. Okay. Now what we need to do is to ensure that we edit the route configuration. So there's already a route table created when we created our custom VPC, which is this one, right? Great. Now this is our main route table. We need to edit this route table to enable our public subnet access the internet through our internet gateways. So what we can do is, first of all, select the route table in the left of the VPC dashboard, so which is this one. Okay. The next thing is to go to actions, select the route table that has been created for us. Let's go back and check the route table ID. So in the VPC and then resource map, so that's the route table ID. Okay, so D1. Let's check from here. Okay, so we need to select the main route table, and that is what I've done here. Next thing is to click on actions and then edit routes, which is this. So now what we are going to do is that we are going to select add route. Okay, so add route and then choose the internet gateway IP address. Okay, that will be like the destination. So this is the destination, and then select the internet gateway. So the internet gateway that we created, which is this one. So this is the internet gateway that we created. Okay, so now that we are done, what we need to do is to select save the changes. So we've edited our main route table. All right, so now the next thing we need to do is to associate our subnet. So we need to associate our two public subnet with the route table that we just edited. So let's select the route table association. All right, so we need to click on edit subnets. Now we'll select the two public subnets, which is this and then this, and then click on save associations. Save associations. Okay, so basically we have created our subnet association. Now the next thing we need to do is to create a private route table, okay, for our private route. So go to route and then create another route and name it three tier private route table dash RTD. So we'll select our VPC, which is this, and then click on create. Now the next thing is to also edit our route table. So edit route, add a route, select the destination 0.0.005/0, and then select the internet gateway. Okay, select the NAT gateway, which is this. Now this is our NAT gateway that we created. So we'll select the first one and then click on save. Now we need to associate our private subnet in our application tier with the route table that we just edited. So what we need to do is to select the route table, okay, and then click on the next, so let's go to the route table, okay, the private route table. This is our private route table, and then click on routes, edit routes. Now what we need to do here is to associate our subnet. So click on edit subnets, select our private subnet, all the private subnet that we created, 1, so 2, 3, and then 4, and then click on save. So you can see we have 4 subnets that have been associated to the private subnet that we created earlier. Okay. So what we are going to do here is that we are going to repeat the same process for the second application tier route table and make sure to select the NAND gateway in the second availability zone. Also ensure it is associated with the application tier private. So we create the second private route table. Click on create. Let's name it as 3-tier route table 2. Select the VPC and then click on create. Now the next thing is to do the subnet association. We edit the subnet, so we select the first private subnet and then the second private subnet, and then click on save. So as you can see, we have associated the first and second private subnet. Okay. Now we also need to edit the routes and then ensure that we add the NAT gateway that we created for the second NAT gateway that we created in public subnet 2. So use NAT. Okay, so these are second NAT gateway and then click on save. Alright, so the second NAT gateway 2 has been added successfully. Okay. So our database has been created successfully. So as you can, RDS has generated your database credentials, master password. During the database creation, it will be displayed in the connection details. Alright. So yes, everything has been created successfully. So as you can see, we have our DB incoming connection associated to our app tier security group. This our app tier security group. So now we have to click on save. Okay. I've already cancelled. Great. So one thing you need to know is that sometimes you might encounter an error when you try to add the application server security group. But don't worry, just select add rule and then select MySQL Aurora TCP 3306 and custom, and select the same application server security group for the source, and just delete the first rule and select save the rules. I'm not really sure why it happens though, but it should be fine. Okay. Alright. So our DB is also created, and our DB is talking to our app tier via the security group. So that's basically fine for us. Okay. Now that we've got our foundational 3-tier architecture created, now let's create a load balancer for the web tier to evenly distribute the load to our EC2 instances. So basically what we are going to do here, we are going to create a load balancer. Now, the first thing we need to do is to navigate to the EC2 dashboard and select load balancers. So this is our EC2 dashboard. Now let's go to the load balancer. So these are load balancers. Select create load balancer, application load balancer. So let's select create. What we are creating here is application load balancer. So as you can, we have 3 different type of load balancers. we have the application load balancer, network load balancer, gateway load balancer, but here our main focus is on the application load balancer. So we click on create application load balancer. Let's give it a name as 3-tier dash web. Okay, and then so this is internet facing. This is internet facing. If you are creating this for our app tier, then you will have to select internal. You get it. So this is internet facing. So we'll have to select our, the next thing is to select our VPC, which is this one. Okay. So default security group, we need to remove it. Now we need to use this ages. Remember, we are creating the auto scaling group in the the application load balancer in the public. So basically, let's delete the two public subnets we created. So let's select public subnet 1, and then this one to be public subnet 2. Okay, all right, and let's select the security group. So here we'll select the web access. Okay, and then but remember to open port 80 from anywhere and on the security group. So when you go to this is what I'm talking about. Security group for our web access, which is this. Okay, we need to inbound rules, we need to edit and then open port 80. Port 80, that would be no, custom TCP, that's port 80, and then open it to anywhere. Okay, and then save. Already exists. Where? Let me check. Inbound. Oh, okay. Okay, so we have port 80. So as you can see, this is port 80. We have port 80 open. Okay. All right. So now let's go back to our load balancer page. Where are we creating our load balancer? Okay. So this is where we are creating our load balancer. So as you can see, 80 port 80 is, and okay. So we don't have a target group. Now let's go ahead and create a target group. So remember that one of the first things you need to do when you are creating a load balancer is to create a target group. Okay. All right. So now we need to have instance to direct traffic to our traffic coming from the load balancer. Now we'll create a target group. Okay. So now we select instances. Okay, instances. And then so here let's give our target group a name. Okay, so let's say web tier target group. Okay, and then so now we'll leave all other options the same, Okay, and then click on create. So this is being created. So our target group has been created successfully. Right. Now the next thing is to go back to our, click on this, refresh, and then select our target group. Listeners and routing. Yes, that's what we just did. That should be in port 8, right? Yes. Message is here. Yes, port 80. Everything else is the same. In the same region. VPC, demo VPC, right? Yes. What else? So why is our target group not showing? Listeners. Let me. Port 80. No resource to display. Let me refresh the page. Because we have our target group that is created. This is our target group. This is our target group. Okay. So let's go back. Instances. Web tier. IPv4. Then everything else will be defaults. Create. Now let's go to the application load balancer. Let's give it a name. Say web tier -APL. Okay, internet facing IPv4. Availability zones AZ1. This should be fine. Remove the default security group and do so demo VPC. Remove the default security group, this and this. So this should be in the public subnets. Listeners, target group, resources. Okay. So now our security group, our target group has been selected. Think we'll leave everything there. We don't need AWS web application firewall. So let's review this and then create the load balancer. So our load balancer has been created successfully. Okay. Our load balancer has been created successfully. So this is our load balancer. This is our load balancer. It's being provisioned. Okay. So when you open it, give you mapping rules, resources, security, monitoring. We don't have CloudWatch or something that's thing. Yes. So that is done. Alright. So yes, basically that is how you create a 3-tier AWS architecture. Now what we've learned from this is we created one public subnet and two private subnets. Created two public subnets and four private subnets. We also created an internet gateway and application load balancer for our web server. We created an auto scaling group for our web and application tiers. Created a security group for both DB, web tier, and then the app tier. We also created a NAT gateway to allow our EC2 instances in our application tier to access internet. Also created MySQL DS that allows for easy scaling. So yes, now the main aim for a 3-tier architecture is to ensure that applications are reliable, scalable, and secure. And so I hope this was very informative and helpful. Stay tuned for more videos. If you haven't subscribed to my channel, this is my channel. Kindly subscribe to the channel. Let's grow the community together. Okay. Thank you for watching this video, and don't forget to like, share, and subscribe.